Hello and thank you for watching this video. Today I will go ahead and discuss about a library in R called profvis, which is developed for profiling the execution details in R. In other words, like it will visualize for us on how R is handling the memory and how R is spending its time when executing the time. The details about this video is available in a Medium blog. Please feel free to read this and follow the steps as you are going. But this video is a complementary to this Medium blog. First, to get an idea on how much time we can save on with changing our programming techniques in R, I developed a simulation. In the simulation, there are three different implementations to do one simple task: getting the keywords from the user and searching about 42,000 plot summaries of different movies and returning the movies that has those keywords in it. And as you can see, there are three different versions. I ran it at the same time. It took 14 seconds for the parallel implementation to give us back the movies. Then lapply or for loop on list took about 24 seconds, and the typical for loop on data frame took about 71 seconds. So with changing the techniques, the programming habits in R, we might be able to save our execution time from 71 seconds to 14 seconds. So let's go ahead and see how we can do that. And for this purpose, I called these implementations the good, the bad, the ugly. This is the good version, this is the bad version, and this is the ugly version. The naming is based on the famous The Good, the Bad, the Ugly movie. I also wrote another Medium blog post which tells us the details, very detailed technical perspective of how those implementations have been written, and also it includes some simulations on how different methods to do the same thing spans as the number of summary plots, number of the movies. Our data set gets larger and larger. So without wasting the time, I will go ahead and show you the R Shiny, and for training purposes, we are going to start from the very ugly version, which took about 71 seconds, and we'll start using profiling techniques to find out where are the bottlenecks in the current implementation and improving it as we are going forward. All the Rscripts and documents are available in my repository. Please feel free to clone it and follow it as we are going forward. I am going to share the links to the Medium blogs and my repository in the show notes. So for this purpose, let's very briefly show you how this how our application is running. I'm not going to go through the details of developing a Shiny app. If you would like, you can go to the Shiny page and the RStudio, and there are tons of templates and cool stuffs there. I also have developed one video on developing a very simple Shiny app. So our Shiny app is going to have three different buttons that each of them are going to call the ugly, good, and bad functions to get the data. As I said, we're going to start from the ugly version. Very briefly on what this function is doing. It is reading the file which has the plot names and summaries. The file is .txt format, so I'm using a read.table with a simple tab separated format. Then this for loop is going all over those data frame. The text, the plot summaries are at the second column of that txt file, so I just set it as a text. Then this simple function is searching if the keywords, which have been, as I showed you in the simulation, those keywords exist in the text. If it is yes, we're going to have 1. If those keywords doesn't exist, this function is going to return 0. Also, I implemented another feature, and that is very naive, simple, counting the number of words in that plot summaries. The reason that I added this is like to adding more load to our program to explain how we can improve the implementation, the execution time of the R Shiny app. And the last step is like creating 2 columns to that plot summaries and adding those the results of if the keyword exists or not and how many words are in the text. Then these 2 lines are just filtering movies which have that keyword, and the last is just another function. I wrote it here in the helper function. Please feel free to look into it, but it is generally getting those key movie IDs and return the name of it. So let's just go ahead and first use the profvis. I'm gonna just extract the ugly version. The file address is going to be, my files are at datasets, plot summaries at txt, and I'm gonna look into 2 keywords. I'm looking for the movies which have love and World War keywords in it. Okay, now let's run the function first and profile it. As you can see, it is profiling. I'm going to fast forward this part because I don't want to waste your time. All right, the profvis has returned our function. As you can see, this is the whole extract text feature, and read.table is taking about like 40 seconds of the time. Like, as I said, there are 42,000 rows, and 40 seconds for read those tables is a lot. And scanning part was okay, but out of those, from that read.table, type conversion is taking a lot of time, about like 35 seconds of that. And there's a default type conversion, and this .external2 is a function that tells us that it is calling some precompiled C programs. We don't need to worry about those, but it is calling some precompiled functions to get that conversion. And GC is just garbage cleaning. So that is something that might catch our eyes. When we see a lot of garbage cleaning, it means that we are allocating, deallocating the memory a lot, and there might be some improvement options there. Type conversion is telling us another thing, that, hey, do we really need to convert the type? Because our file includes text files, and R by default try to convert those text files into factor, because it finds it very easier to do statistical analysis when we consider like the factor instead of string. Okay, so far by analyzing the profvis flame graph, we have noticed 2 things in our scripts. First one was a lot of like garbage cleaning time, and it is because of a lot of memory allocation and deallocation, and I discussed very thoroughly in that the good, the bad, the ugly, that by using list instead of data.frame within a for loop, we might be able to eliminate a lot of like memory redundancies. Also, type conversion is taking a lot of time, and it is basically because our txt file includes a lot of strings, and R by default convert them to factor. And in this example, since we have very long text files, it took a long time to change them to factor. Although like factor by default is very helpful for a lot of statistical analysis where we want like hot versus cold to be considered as factor instead of like some strings. But this is not the aim of our study here. And in addition to those two, I would like to move your attention to this end of file with encoded string error. The take home here is please try to avoid this warning message as much as you can. And I explained again in that the good, the bad, the ugly, setting the quote to nothing would be one of the solutions to that. So we are going to copy reading in the file into our bad version. It's gonna with the same separator. To avoid end of file, I'm just gonna set the code to false, string as factor, strings, sorry, as factor also should be false to prevent us from that type conversion. For this to save garbage cleaning and memory handling, we are going to change the plot summary into a list and do the for loop within that list. Plot summary, the first element of the list. And the text, similar to the data frame, it is going to be the second element of the list. And within that list, it is another list. So that plot summary is a list of lists. And the ith element is going to give us the text file we are looking for. Once we have the text, we are going to copy and paste. Part of programming is copy and pasting. So we have the same text file, so we are okay. We only need to extract those two. And at the end, we need to put it into a new list. Let's call it keyword. The ith element is going to be the word exists variable we just set. Word count is the ith element is going to be the word count we just implemented. Again, filtering and getting the movie name are the same between those two. We can just copy and paste because this plot summary is the exact same name as this plot summary. So now we have the code. We disable the quoting to take care of end of file error. We change the string as factor to disable type conversion, and we changed the whole script to use list instead of data frame. Now let's go ahead and run this function and the profile link. Again, I'm going to go ahead and fast forward it. Now get the flame graph from the bad version of the code. As you can see, our execution time is now 22 seconds. So it used to be like 63 seconds, and now we are 22 seconds. Huge improvements by just very minimal changes. Read.table now only has scanning. It doesn't have type conversion. It doesn't have those garbage cleaning, and the rest of the time are being used to extracting those two features. There are some other packages written on top of the base R read.table function. fread on data.table package is one of those which are being known to be very fast reading very large files. Also, looking into the second part, which are the main feature extracting part of the program, you can see there are a lot of like serial, lapply, str splits, and sapply functions. And so the only two improvements we can do, or I think I could do, maybe you can come up with some other creative ideas. If you have, please feel free to let me know. are using like data.table package to improve even like reading the files even more. And the second one is using parallel. Here I use foreach function to run these lapplies more parallelly. Okay, so since the aim here is not like explaining how to do the parallel, I am not going to write it down for you. I have the functions ready and it is over there for you in the repository to check it out. That's the fread file. It doesn't need a lot of like inputs. I just use fread general function. And these three are kind of common when you want to use parallel computing. It just set up the infrastructure for R to be able to create new sessions, forking the sessions, running in parallel, and getting back the data. And this function, detect cores, like giving you how many cores does your current CPU have. And the major part of the parallelization is here using foreach. It actually chop the data sets into smaller part, giving it to different cores. They are returning two things. If the word exists, the exact same function we had in ugly and the bad versions. Also like counting how many words are there within the plot summary. So they are, the other take home here is like when you're using foreach, try not to create any internal variables. As you can see, I combine those two functions and returning it back into a new data frame. So I'm not creating any overhead here because it might pollute your memory while doing it. Then I set it up as our two famous column names, keyword and word counts, and famous filtering and getting the movie names. So I will go ahead and run it, but like our function, our text file is in data sets. So I will import those two libraries, run the function, and starting profiling. Awesome. Our profvis results is available. As you can see, our data fread is taking like less than 1 second, half a second. That is amazing. And you can see there are a lot of like parallelization is going on here. Here, this part, like the second half, like the second 4 seconds, the main session is getting back the data and like binding them together and returning it back. So the other thing I would like to mention is the flame graph only shows you the time that the main session is spending. So it doesn't show you like the time being spent in each course, which is okay because like the main session is the place that handles most of the load, and you can find out like how much time it took to run the main function and how long did it take to get the data back. As I discussed in those blogs, if your function is simple, if your data set is not big enough, you do not need to worry about like doing parallel computation because these overload seconds might not help you with anything, and it might even like increase your running time if you compare it to like for loop with list. But here, since our functions were like heavy enough, we are seeing a lot of improvements from 22 seconds to 8 seconds, which is really good. So as you can see, by using profiling, you can find the bottlenecks, where to start improving your scripts and reducing your execution time. I hope you enjoyed this video. Thank you very much.